Welcome to a presentation on the NIST SSDF Distilled. My name is Marty VanWinkle. I work at Institute for Advanced Study, and I program things sometimes. From 2000 to 2005, when I was a student at the University of Arizona, I worked at Arizona Research Laboratories. I did a lot of programming for them. 2006 to 2013, I went corporate. And 2013 to present, I'm back in higher ed at IAS@edu. And all of the materials for this talk can be found at the URLs that are listed below. So, I mean, I'm going to take a second to allow you guys to write that down or access the link or take a picture of it. All these slides are available on the website for the conference. And I'm going to be talking about the existence of material in those directories or in those things. So they're good links to have. And there's Jay.
So, unlike what it said in the program, my job title is a risk advisor. It says Mr. I'm not sure what a Mr. would do, but I'm a risk advisor at Duke University. I deal with questions that come at me like, can we comply with fill in the blank? I have familiarity with NIST primarily around 800-171. If any of you are dealing with Department of Defense type research, you'll know what that is. On the side, in my spare time, I do vendor risk assessments. Do you know about what third-party pieces are in that vendor that you want to do business with? And I run our 1Password implementation just for things to do it fun. Throughout my career, I've been in an environment where I had to be comfortable at 40,000 feet having discussions with people who weren't technical at all. 20,000 feet where I had to know enough about what the topic was to be able to carry on an intelligent conversation with people who did. Every so often, I've been all the way down at the ground doing things like virtualization. So I've learned how to shift depending on what my audience is.
So this is a blurb about NIST. It was founded in 1901, and it is part of the United States Department of Commerce. It's one of the oldest physical science laboratories. Its mission is to promote U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology in ways that enhance economic security and improve our quality of life. So blurb about them. For this talk, there's going to be, the goals. We would like to reduce the barrier of entry to the secure software development framework. And we're going to do that by reducing the cognitive load associated with reading the material. And accessibility is also going to be a part of that. At the end of the presentation, you should have a good feel where like the big structure of the SSDF. And you should be able to identify which elements of the SSDF correspond to work products. So you'll be able to say, this was a problem associated with this specific security thing, and administrators, managers, programmers, they can all use the same words to describe the work. So we're going to do an introduction. The core part of the presentation is going to be the distilled SSDF. And there's what I would call a reading assignment. It's just a 2-page markdown document that has the headings and certain subsections of the SSDF in it. And then after the core presentation, we're going to do QA and ask stuff about the audience, or more stuff about the audience. So the framework, and this is from their website, is a set of fundamental sound and secure software development practices based on established secure software development practice documents from organizations such as BSA, OWASP, SafeCode, and probably other places. In the form of a Jeopardy clue, you could say, this framework helps you map a problem with secure software development to a set of solutions. So we would like to ask the audience,
if we could see them.
Yes. How familiar are you with the SSDF? And
so we'll start by, if you don't know what it is at all, you're fine. Just stay seated. If you have some limited familiarity with it, raise your hand if you've at least heard of it, okay?
Oh, wow.
And if you seriously think you're like Marty and you're rocking it, stand up.
All right. Hey.
Whoa, there we go.
Wait. Okay.
Cool.
That's cool. Good. Okay. One of the things that can make a framework from NIST seem daunting is the fact that it's huge. And so, you know, I like to say that this framework itself is something that you align yourself to. You can, of course, you can implement it, but to make it easier to consume, you align
Quick
with it. Sure.
aside, I'm just how many of you have a familiarity with any of NIST documents and standards? You've looked at them. Okay, so you know what he's talking about in terms of that level of complexity that's in the documents that they release.
Yeah. For example, you map a problem to a set of actionable items. Let's just say a bug report comes in for a security issue. That would be under responder vulnerabilities. It's like incident management and stuff. And environmental risk analysis, sensitive research environments, you would find it and prepare the organization. And bottom bullet is use it as a guide to identify, prioritize, and fix weaknesses. So why would you want to use the SSDF? It's good. In my opinion, it is a very good document. It is extensive. There's a lot of stuff in there, lots of useful stuff, and it can serve as a guide. But it's not presented in a good way for you to get an overview. So this is the way the SSDF is presented. It's in a spreadsheet.
No problem with that. You can figure out what you want to do, where you need to do it. But that's how you find things from NIST. There's a lot of information crammed into a spreadsheet. I think we all have learned that spreadsheets aren't the best way of doing things, but sometimes they're the easiest way and the most accessible to a broad audience. At least if you put it out in a spreadsheet, it's there, somebody can open it.
Yeah, and so that leads to one of the reasons for this presentation. When I say I can't read something, I mean I can't read it like it's a book or whatever. Of course, I can look at the words. You know, I can see the letters. I can parse the letters. But then you end up looking at different columns and stuff and kind of getting lost. And it really is not good for an overview. And I can read what my script generated, and it's reasonable on a reasonable resolution. You can read it. It's printable. Like, yeah, I still use paper for certain things, just cause. And I'm a nerd, so yes, I read this stuff on my cell phone. I write parsers to convert documents that I can then read on my cell phone when they're presented in a bad way. There's a wall of text ahead. You don't need to read it, but the point is that it's legible. So the script takes the spreadsheet and turns it into something like this.
This is the 40,000-foot view of what's in that spreadsheet. And if you think about that spreadsheet, it kind of runs left to right from 40,000 feet on the left-hand side. Get in the middle, it's stuff that you can use at that 20,000-foot level. The action items, the things that actual people doing code or fixing code are in the far right. That's the ground level.
Yeah. So, like Jay was saying, the 40,000-foot view, or to get to the 40,000-foot view, it's generic. A lot of stuff when you're looking from that level is just a good idea in general. And you can find a lot of common themes between that and other NIST documents. So the way that the SSDF is set up, there are things called practice groups. And practice groups are prepare the organization, protect the software, produce well-secured software, and respond to vulnerabilities. Practice groups have practices, and practices have tasks. So these next two slides are going to be the 40,000-foot view. And I'm going to pause on each one of the slides and give some time for the audience to read them. And when you're done with them, you can think about what happens if you don't follow what the advice is. Some of it's going to be very generic, and you could go down a rabbit hole of thinking about things, but it might help to get it get you thinking about it. So this is slide 1. I'm going to wait for about a minute or two.
Curious, does anybody not find something on at least these first two that doesn't ring true in your organization?
Yeah.
If not everything, then probably a majority apply at one point or another.
I'll let it go for another 30 seconds about. Yeah, read them and think about what happens if you don't do these things. Oh, come on.
All right, let's
Okay,
see the
yeah.
next one.
Sure. And here's the other one.
And you'll see some of it's proactive, some of it's reactive.
Yeah. About 30 more seconds on this, I guess.
Next curious question I have is how many of you actually write code as part of what you do? Just show of hands.
All right.
Okay.
Cool. Some programmers.
That leaves a lot of people we don't know exactly what they do. We'll have to find that out. Fair enough. If you don't write the code, do you support people who do write code? Or supervise or manage people who do? Okay, so
Yes.
you're tangential.
Okay. So if you have an idea of what's on these two slides and you're looking to learn more about the SSDF, then I would recommend reading. That is a hyperlink in the document, in the PDF that's provided. You could click on it and it'll take you right to the markdown document. I would recommend reading it, and that gives you what we would call the 20,000-foot view of the SSDF. And so the key takeaway number 1 is if you have a problem with software development that relates to security, then you can use what's in the SSDF to classify the problem and find solutions. And this is a personal opinion, but don't make doing what's in the SSDF difficult. Use it as a guide to tend toward things. So if we were to look back at the SSDF, or the big document now, the bullet points that you read are the leftmost column, and they're the practices. And the reading assignment that I mentioned before contains the left 2 columns. And there is another parsed version of the document that contains everything, but it's linear. And then I uploaded another one without references too. So if you go to the GitHub directory, you'll find a couple of documents there. So looking at this, the leftmost was the 2 slides, and the 2 left ones are the reading assignment.
And note, this is only a few of the rows that are in there.
Yes.
The rest of it's, typical NIST, lengthy.
Yes, so the reading assignment's 2 pages, but the actual, the NIST document in Markdown form without references is around 15 pages. So for examples, we're going to propose use a generic organization where it has a centralized information technology group, and the organization, you might have more control over this group than you do the research programmers. They're out in the frontier, they're writing things that interact with whatever it needs to interact with. But they work on similar things in different ways. It's just a mix of stuff. Just
out of curiosity, thinking of those 2 as an alignment, if you align yourself more with central IT, raise your hands. So a couple. If you align yourself more with the Wild Wild West, raise your hands. Okay, so we've got a mix. Some folks that are out at the edge and some folks that are central.
Yep. So When I have had discussions with people who do programming in research environments, it ends up just being shoveling data from one system to another system. I log into something, I download something, and then I get it into another system. It's just, it's shoveling bits. Unless you are working directly with the equipment or doing something, it's just data transfer stuff. So let's just say you have a program that grabs a subset of data from somewhere and it puts the data somewhere else, and it might create file names that are named after the subset of data that you're grabbing. But there's a bug in it, and if you have data in a field that is formed in a certain way, it can lead to some sort of arbitrary code execution. So that's just an example. There are lots of relevant SSDF sections, but you would go to the respond to vulnerabilities thing, do the incident management stuff, identify and confirm it, assess and prioritize and remediate it, and then identify the root causes. And then in this hypothetical thing, let's just say you confirm that the bug exists and the impact is hopefully limited, but you could have prevented this using some sort of static code analyzer. Let's just say that you had an unquoted string in a bash script that used data from the data set in an unsafe way. So you would then apply a, say, static code analyzer, or at least a linter or something, in order to review your code. And then there's a part where you would then apply that knowledge to other stuff. It's all there.
There's a catch. You've got to start somewhere. You've got to set some stuff up. So what we thought we'd do now is, what are some of the basic ingredients that you need to kind of get started down the road of doing the things that are laid out in this? And shall we just poll the audience and see what comes to mind while we jot down what they say?
Yeah.
So if you know of something that you think fits, you need to have in order to be successful at doing this, raise your hand, say something, we'll start jotting them down.
Anybody?
Hey, dead. No ingredients. Wait a minute. There's an ingredient.
Right.
Revision control.
Okay,
Excellent.
that works. There's one.
This might derail it, but just going through the NIST guidelines, you can also evaluate this what you already have.
True. You can do a shopping list and see what you have and figure out what you need to buy. What else do we need? Just think really basic ingredients. All right, so let's take them to the store and get some.
So revision control is, in my opinion, the first thing that you need. I have run into situations where the only location of the code is in some system that's highly tied to the instrument or something like that, and they don't really have a way of either porting it back into a revision control system, or they have some roundabout process for writing code and then transferring it or whatever. Getting revision control as close as possible to the code is the biggest one. And you need to make sure that you have that set up for research programmers and for your central IT staff. This allows you to do more in an automated fashion. If you don't have access to the code, you can't do anything with it. Backups are a big one too. You don't want to lose the code. Ticketing systems, something that generates a unique identifier for you to reference in commits and branches, so that like this ticket fixes this specific thing and this commit implements it. And it also can explain why something happened, or like it keeps a log of stuff.
Has anybody ever had to deal with code that somebody else wrote that's not working now, and you're trying to figure out why? Never.
Never.
Can you see how maybe doing the stuff there might have helped a little bit?
Yeah. So, and a knowledge base, and I think of ticketing systems and knowledge bases as two different things. You can have systems that merge them, but ticketing systems, it's a journal, it's a log, like why we did this, when we did this. A knowledge base supposed to be curated, right? You can curate your logs and your journals, but the knowledge base needs to also exist. So that would document your environment. And having these tools covers a lot of topics in the SSDF.
And I think, let's see, just show of hands. Anybody in the audience or on stage who loves to document?
I actually,
Okay, there's a couple over there. Notice that the person who raised their hand and said they thought they had a handle on this also likes to document. There might be some correlation there, but honestly, I think most of us either say we just don't have time to document or we're not good at it. It doesn't matter. If you start doing it, you start seeing the benefit, especially if you've got people leaving your organization. Having that documentation in place at least makes it a little bit easier for someone to come in and sort through what was going on and figure out why things were done. So
yeah. The other thing, it's an important point at the bottom. You want these to be carrots, and you don't want it to be sticks. No. You don't want to beat people over the head with your ticketing system, or There are ways to implement processes so that they don't get in the way, and so they're not painful. Otherwise, you're just going to look at people subverting that process. So this is where we'd ask the audience, do you have wikis and ticketing systems? And yes, do you feel that you have all this stuff in place in order for people to use it?
Show of hands, how many of you think, at least centrally, you've got the basic ingredients to get started? Okay, good. Now I'm going to put the people who didn't raise their hand a little bit on the spot. If you didn't raise your hand, would you mind saying what in that short list you don't have? Just curious.
And if you didn't raise your hand because you didn't know, that's also a valid thing.
The other thing I think is important is most of what you just saw in that basic ingredient list is not exotic in terms of cost. You can get these things, so cost is not a reason for saying we can't do this because we can't spend for it. You can find something for most of this stuff in a reasonable price range. You can find expensive things to do some of this stuff, but you don't have to buy that version.
Yeah, spool up a VM with MediaWiki on it. I mean, it's pretty easy. So so we're at the end of what I would call the core of the presentation to get people like links and the information about the stuff they would need to understand the SSDF. Because we didn't know the distribution of the audience or how many people to expect, the Q&A session can be open, right? If you have any question about secure software development or any components of the SSDF or stuff like that, you can just ask, and we will totally discuss that stuff with you.
So with that said, feel free to walk to the mic and just kind of say, I came here and this is a problem that I'm having, or this is a curiosity that I've got, and let's just see if we can get a little bit of discussion going. There we go. At least one brave soul.
Is the center microphone on? Okay, it should be on now.
Oh, there we go.
Thanks. Good morning. Great talk. I know a little bit about 800.171, and there are controls and there are audits and things like that. Is it the same thing with this?
It's a little bit different. I live in the 800.171 space. That's more prescriptive for getting something specifically done. This is a little broader, and there are some correlations, though, because if you take 800.171 and you strip it down, not everything is a cybersecurity control. There's some training stuff in there. There's some physical security stuff in there. It's not nearly as cleanly defined, I think, as what you find in this particular standard, in that you've got very specific areas that apply to a certain set of operations that you're taking and the prescriptions for those. But it's still NIST. It's still, in fact, one of the things that happened this past week, CSF 2.0, I think, if I've got my acronyms, those of us who live in acronym soup, 2.0 was released. And so I reached out to Marty. I said, hey, can you take this other unwieldy, messy-looking document and run it through the script? A little while later, he says, yeah, it's here. And sure enough, there was this brand new document from NIST. So the tool that he's developed for parsing these things back out into, like he said, readable format is applicable to more than just this particular one.
And there is a mess of scripts and stuff. So my talks directory on GitHub contains what I would say a curated collection of documents. I can move the CSF stuff in there too. The CSF doc has a little bit more of more formatting that I could apply to it, but it's definitely more legible in that form. So yeah, I will action item. I will move the CSF to the talks directory.
Who else has a question? Yeah.
So I work for a vendor, so like raising my hands at different times probably didn't make a whole lot of sense. But I talked to a lot of different universities, and the stuff that you put up there about, you know, code revision control system, ticketing system, wiki, backups, I think in my experience, most institutions sort of have a handle on those basics. Like we've got that. Where the software development sort of life cycle breaks down for a lot of institutions is when you start bringing in more externals, like where are you sourcing your software? How are you integrating with external systems? What about systems you're not hosting but are hosted by other people and you're integrating into it? Does the SSDF sort of address concerns with those sorts of things, or is it mostly with simply code that you're developing and only code that you're developing?
There are sections in the SSDF for software bills of material and for provenance and stuff. There are other documents that might be more thorough in telling you exactly what you would need from vendors and from third parties when you get their software, but it is a part in there. It's like, you need to be doing this. So
I mean, you touched on the big one is the SBOM, right?
Yeah.
You've got software that you're bringing in from all these other places, and then you're writing this little bit of code to glue it all together.
And just out of curiosity, show of hands, does anybody not know what SBOM is? Okay, so everybody's heard software bill of materials. Wonderful idea. My personal opinion is it's not quite ready for prime time to make actionable
Not
use
ready
of
for
on
prime
a-
time yet, but required by certain branches of the federal government, among other things. And so that's kind of a question I had for you and maybe for the audience here is, are we starting to see actual implementation and use of SBOMs and the like within higher education? And I'll go sit down.
No, that's fine. My opinion is it's getting talked about in some of our higher ed groups. It comes up. I chair the EDUCAUSE NIST 800-171 compliance group, and it's come up there because you start talking about your allow list software and things like that. Well, how are you going to make that determination? It's a great idea, but are we at a point where we're going to be able to get that from some of the esoteric software that's used in engineering and science and those fundamental research areas? I'm not so sure, and I'm not sure that higher ed is going to be the one that can hold their feet to the fire to make it a priority to do that.
Well, I mean, like, I think the biggest and best example is Log4j.
Yeah.
Like, okay, we had this software. Where do we have this software? Actually, nobody knows. It's in there, it's everywhere, but it's running on who knows what.
Trust me, a number of jokes at my expense with my name being Jay that were made by the rest of the cybersecurity team at Duke. I heard more than enough about Log4j, but yeah, it's that, or it's things like, oh, do you know which software you might have that's using MoveIt in the background? Well, maybe it wasn't, we found out, and we're still finding out things like that. And so we've got to get to that point because you're right. You don't know, centrally, you don't know what's where across the broader landscape of the entire campus.
So there was, when I was making this presentation and the materials for it, there was a slide that had Log4j, just like question mark, back when it was hot, when it was a hot topic. Damien and I had a conversation yesterday about containerization, and with regard to knowing what you have installed, there was one more point that I kind of touched on, but I didn't succinctly say it, and it's that when you have something like a Docker file that has things that can be run, like Turing complete things, like it's not a configuration file. It's not something that lends itself to being to have static code analysis done on it, right? Because it's just sourcing out other things or running other things. You don't know what it's fetching out there or how it's fetching it. Is it using curl or wget or what other stuff is being installed by the container that is outside of, say, a package management system. So this also gets into the software bill of materials. It's like, what is this thing actually doing?
Well, right. In an ideal world, every container would come with an SBOM.
Yes.
Yeah.
Yes.
Well, and it gets also to that point about the documentation. You know, you're writing code, but you're pulling it from various and sundry places that, for now, may be deemed reputable, but when something hits and some subsection of code from this particular repository now has a revision to deal with the vulnerability, how do you assess the need for that in your organization? And unless we get to the point where we start building internal SBOMs for the larger code projects that we're doing, you know, at least documentation could potentially give us a way to search and say, oh, we put this in.
Yeah, it gets into messy stuff when you have things that just can go and fetch stuff from anywhere. You know? More questions? We have a little bit more time.
Yep, question over here.
Yeah, so you know, I write some code, but I'm not in parts of the organization where I pay a keen attention to the standard space of what's out there. But I know empirically that I've long been lamenting the lack of standards of this nature and coverage and quality, right? So, so I came to this talk because I'm excited that something exists now, that something was written by NIST that has at first glance, has a pretty thorough coverage of the topic and focuses on organizational changes and not just like mechanics of what you do while you're writing the code. Like, you know, OWASP was never never a good source of how to write code. It was always just the source of what particular techniques to avoid, right?
Right.
But in your opinion, what sorts of deficiencies or shortfalls does the standard have? Is there parts where it could do a better job? Is there some blind spots in it?
I personally think that the biggest deficiency is barrier to entry and actually reading the thing and understanding it. Like that was number one, just getting a handle on it. If you go and read, like I highly recommend that you read the documents in their parsed form so that you get an overview of it. That's deficiency number one. Deficiency number two, which really isn't a deficiency, it's more like how do you approach it and how do you get into it? Because for other NIST documents, if you've been to presentations where they had like 5 people up on there and they're like, I work in this one portion of this one spreadsheet, right? And somebody's like, I cover 5 portions of this, you know, spreadsheet or something. A lot of times it's like untenable for a group of 1 to do any of this stuff, or at least to get some sort of change implemented. So not a deficiency of the SSDF itself. To give you an example, in one of the portions of it, they say pay for penetration testing or perform penetration testing on your environment if you have the resources available, right? And in my opinion, the entire document, yes, it's good, and yes, you do want to do all that stuff, but from a small team perspective, it always is based off of if you have the resources available, right? You can't let it get you down that you didn't have time to implement something and make it inexpensive or whatever. You know, it's just something that you work through and you build upon what you've done yourself.
And I think to that point, and it's really kind of outside of the purvey of what NIST does when they write these documents, but for this one, the basic ingredients that we came up with, that's not really anything they wrote. It's kind of like, if you look at these things, there are some things you've just got to have throughout. Similarly, for anyone who plays in 800-171 space, 110 controls, but it doesn't give you much in terms of what's interrelated, and if it's interrelated, which is it advantageous to address first? So, you know, NIST lays everything out, but that kind of tends to be what's missing is implementation, or before you get started to make this recipe, have these things on hand.
Yeah, you should have had your oven preheated by now. You know,
Oops.
Like, yeah. That in the SSDF that doesn't happen much. You just look at it and you're like, they're talking about you need to have a knowledge base and you need to have a ticketing system. So. From a standpoint of what it doesn't cover, and they do talk about it. Actually, no. So they do talk about how what you learn you should be applying and folding back into your projects as you're doing this, and making it so people don't need to repeat the work that was done. The end result of that, or one of the end results, should be project templates, right? And when you start a new script or a new program, you need to know a certain set of things like the distribution or your target platform and all that stuff. Okay, fine. What does your project initially look like, and what are the things that are there in order to assist with that? So you should be building that stuff up for your platforms and abstracting that and then applying that to new projects, and basically working the new stuff in.
And so from a 40,000-foot view and a university view, I think one of the things that you'll still have to grapple with is you can pretty much get the central organization all rowing in the same basic direction and sharing the information. I think it becomes a challenge in a research to get that information out to the edge, to the research labs, and to make sure that they benefit from best practices that you develop inside of your central IT. True, they are possibly dealing with things that are somewhat different, but I think there's more similarities than most realize. And so figure out, and also the other challenge from a central standpoint is you don't always know where code's being developed across the campus. There's just no way of knowing. You can't rely on your research management to go through and say, hey, IT security, this project with these people is going to be writing code. That's just not a doable thing. So I think the biggest challenge will be getting it out to the edge and making them see it, as we mentioned earlier, as a carrot, and you've got to figure out how to incentivize that. And that may be, do you manage the wiki resource and just give them access? And do you manage some of these other things depending on size and help them to facilitate? So that's a consideration to think about.
And this is, so right now I'm mentally in the code space. So to give you another thing, have you heard of, what programming languages do you use, if you don't mind my asking?
Java.
Okay. I'm not terribly, what build processes? Do you use Maven or? Maven. Okay, okay, all right. So Java and Maven stuff, Damien and I were talking about it. Okay, so there already is stuff in place in Maven for you to know how to organize a project, right? Where to put files and for your build processes to work, right?
At a basic level, yes.
Okay, all right. So, Maven in my opinion, because there's at least some structure around it, is not a bad starting point from the perspective of, say, when you improve your Java projects, you could then fold it back into other Java projects, right? There's some framework there, right? I don't use Maven.
I mean, yeah, that's true, but you're also talking about higher level stuff, right? So you're talking about you know, not just the core build system stuff, but you're also talking about you know, I guess the build process automation is partially taken care of there to a point, but the code scanning, you know, so that's a separate integration, separate tendrils into that other process. Artifact generation is, of course, taken care of, but once again, you can take that further. I agree with you that that particular choice of technology does give you more, you know, training wheels on your bicycle than many others, right? But there's definitely a lot of scaffolding that go into, you know, how do you spin off a new project that has integration to your build system, to your code scanning system, to your artifact publishing system, to your, you know, all these different durable places or even ephemeral places that your code has to pass through before it generates a finished artifact. And of course, there's the problem that if you're developing across multiple stacks, in each of those, you're going to have a different tool chain. You're going to have a different, whole different setup that you then have to possibly replicate for each origin environment.
And I think that's a place where your central resources, if they want to improve this for the whole of campus, you can't put that much workload, the scaffolding piece, out to the edge and expect the edge coders to also take the time to do this and, do the research that they're actually getting paid for. So I think if you want to make a go of this, like many things, stand up as much of that scaffolding in the documentation on how to use it and make it accessible from the central. And if, you know, one step further, if you have the ability, provide someone who can actually do a little bit of support if there are questions. Because a number of things with the best of intentions will get stood up, made available, but if you get stuck, what do I do now?
So I just want to make another point,
Sure.
Which is actually a realization that just came to me, even though it probably should have occurred to me years ago. But the various, you know, low code, no code sort of software environment solutions that all have this high in the sky promise of, oh well, the workers just have to write the you know, the meat of the business logic, and you put it into this magnificent system that knows how to enrich that code with all the details of this larger pre-configured environment. And you hopefully get the result, you know, like your data spade example. It's great for that kind of stuff. That is, you know, not an ideal environment for many reasons. However, it does sort of satisfy some of the difficulties or some of the things that this document appears to task organizations with developing in terms of provide an environment that is managed, right, that has all the right parts, and then allow, you know, make it easy for your developers to develop code that benefits from that managed central core, right? So that sort of software architecture of a low-code platform is essentially designed around a very similar set of design assumptions. Of course, there are oftentimes other problems with it, like oftentimes they don't provide revision control, they don't provide, you know, they don't often provide many of the things that you would want to have, but the architectural model appears to be similar to an idealized version of how you would satisfy many of the organizational requirements that are laid out in this document?
Yes, it would. Yes, it would have to be. And there's so much stuff there. When you start talking about low-code and no-code systems, somebody already had to have done the work, right? And so what is the work, and what is the scaffolding that was done, and all that stuff. And to tie it back to one of the reasons why it's good to have Jay up here is, like the top, the people, managers and stuff need to realize that the scaffolding, the infrastructure, the stuff that needs to be put in place in order to, say, potentially get to a low-code or no-code environment, that is work in and of itself, even though it might not represent a specific product. So that's where what you said took me. It needs to have already done. It needs to have already been done and done well, and making sure that it stays that way is work that needs to happen. Any more questions? Or topics?
Going once, going twice,
Yeah.
going to Nick.
I'll ask one question.
Sure.
So I've talked with Jay and Martin quite a bit. One of the things I'm curious about is that you've talked about the edge, and I don't talk, from my position in the community, I don't talk to people directly on the edge on your campus very often. And so I'm curious, what are they thinking about some of these requirements? So like Jay, you mentioned they want to focus on their research, but now this is layered on top of all that, along with all their other administrative work that they need to do so that they can focus on the research. What's their sort of feedback or reaction been when you've engaged with them on this?
I think, one, to get feedback, you have to seek feedback. I mean, it sounds stupid, but it's true. I think the other thing is, and we certainly have better tools today than we had, 10 years ago, where everything was like listservs and things like that. I think building communities within your campus to share and be able to ask questions. I mean, we're doing it at scale now across universities with some of the projects we've got, where you've got a Slack for this or a Slack for that. But part of it is awareness, and it's awareness that, one, you've built something centrally that's available to use, and here are the benefits of doing so, the carrot. But it's also, I'm trying to do X, and getting an awareness of who's trying to do what and where. And it's an ongoing process, because typically, on most campuses, it's central IT here, unit IT here, the unknown here. Sometimes that communication, you're at the mercy of what this person the person at the unit level wants to prioritize. And they've got to, all of them get pulled in 1,000 different directions. You offering something that may only affect some small group, getting the airtime can be tough.
So, and along the lines, or those lines, one of the biggest barriers to revision control is data stewardship. So you don't want to check in private things like passwords, and you don't want to check in research data, or at least huge data. You don't want to blow up the repository and check in like large amounts of stuff. One of the things that I think central IT needs to do is go out and contact researchers and say, why isn't your code inside a revision control system? And they might say, well, it's because my configuration file lives locally next to my script, and my script looks in its directory for that configuration file. That configuration file has a password in it, and I don't have the means in my programming language in order to move that configuration file to a protected directory in my home directory, and I don't have the means to get it to reference that. And so one of the things that I have done is I look at people's code and I think, why isn't this in revision control? And I give them, in Python, say something that looks in their home directory for a JSON file containing the credentials for the database that they're connecting to. And then I also show them using argparse how to get command line arguments to specify a different location for that configuration file. And then you give them a good git ignore thing, which might exclude the data directory that they're dumping stuff to, if they happen to be dumping it into the same directory that the thing is, which has its benefits and stuff. So if you set up the stuff that allows them to get the private information away from the script and make it so that they're not committing gigabytes of data, then you can just tell them, okay, git add, git commit, git push, you're done. Like I think that the processes and when you read, say, information on how to use Git, and they say your commit messages should look good, you should have these things, and I totally disagree. For big software projects that are established and that are already in revision control, I agree. The commit should have the ticket number in it. The commit should have a description of the affected component, what it did, whatever. You standardize it for big projects. But for people who are just, trying to, for example, one of the projects that I was given when I was a student, instrument would give the results of some analysis in a triangular matrix, but it was paginated. So they would give you this part of the triangular matrix and then this part of the triangular, and it was like this. And so they were like, we need it to look like this, all right? And somebody showed me, how to not commit the data that was, being used. And there were people who showed me how to set things up so that using revision control was easy. And yeah, the management and stuff needs to realize that they need to push that stuff out and make it easy for researchers. Any more? I could talk about this all day.
So I would turn that question also around to the audience. What's the challenges you've had around getting your researchers to do some of this? Because they're the reason why we have organizations, and we have jobs. But it's why are they not doing this? Are they just not aware, or are they focused on other things? Any comments from the audience?
All of those things. Unknown unknowns, per Donald Rumsfeld. You don't know what people are up to. Lack of communication channels, lack of time to really chase down this basic stuff.
To that point, centrally in your IT structure, management is far more likely to see it as a priority and make the mandate than you are if you're out in a research lab and it's a PI who's trying to finish off a grant, get the data, get the results. I've yet, in few exceptions, I really don't see security, forward-thinking, proactive stances being something that's general practice at the lab level. It just doesn't seem to be. And there are exceptions, but.
Well, it's the difference between I have an application that 25% of the university uses versus I have an application that one person uses.
Yeah.
That's the researcher.
Right.
One
Yeah.
person uses that application. It gets a lot less attention.
Right.
Yeah, but sometimes
There's a breach,
sometimes they leak out into the wild, right? So sometimes you have something where a couple grad students are putting together something, and then
I get more
a couple months later, there's a press release and a public website, right? And so these things have a way of becoming big on a timeline that other parts of the organization are not really aware because they're removed from that process. So it is a big risk, right? But it's hard to catch these things ahead of time. It's like whack-a-mole, but the moles are in the back of the room and you can't even see them, right?
and your club's not long enough.
That's why you know, I see a lot of parallels with just general shadow IT stuff, right? So why do people feel the need to maintain Excel, you know, artisanal Excel sheets with custom macros and changing colors when, you know, if the organization makes available like a custom web development team at low to no cost, right? Some people are just attached to their esoteric tools and the lack of, you know, the benefit they gain from not dealing with central management, right? But then the drawback is you get a proliferation of these artisanal solutions that no one else is looking at. So I wonder if we, you know, maybe even going back to that low code analogy that I was invoking earlier, if we provide folks better systems in which to do citizen development, right, then that is an effective carrot, right? Because if you don't give them that, then your only other solutions are just sticks, which is, I found out about you, now you're going to change because I'm making you change. And whereas, you know, if you make it easy for folks to develop their data spades in your environment, in your service, as opposed to, you know, oh yeah, I found this on GitHub, clone. You know, if you can show them a new way of doing it and sort of unteach, you know, yeah, code is tremendously powerful, but it comes with responsibility. It comes with the responsibility of the stuff you put out. And if people get too happy and use it, then you're left with all this cruft that we want to avoid.
Yeah, yeah.
And that's where you've got more 40,000-foot conversations to have.
Yeah, and I have code examples if anybody wants code examples for Python, Perl, PHP, Ruby, Bash, for how to load credentials outside of a repository directory. Shoot me an email. So, yeah.
Thank you.
Yeah, thank you. No, this is.